Did you know that every color in your closet depends on just one tiny atomic switch? Think about your favorite shirt. Maybe it's bright red, deep blue, or perfectly black. But what if I told you that these vivid colors all come down to a microscopic change, often inside just a single atom? The secret is hiding in the very structure of matter itself, an invisible dance that determines the rainbow of hues we see every day. Let's zoom in, way past the thread, past the weave, right down to the molecules making up the fabric. Here, atoms are not just static dots. They're dynamic, with electrons orbiting their nuclei like planets around a sun. In dyes, the chemicals used to color fabrics, these electrons can jump between energy levels. When an atom's electron absorbs light, it hops to a higher level. But here's the catch, only certain jumps are possible, and each jump absorbs a specific wavelength of light. That means, the color you see is actually the light that wasn't absorbed. For example, when a dye molecule absorbs all the wavelengths except blue, your eye sees blue reflected back. But what determines which wavelengths are absorbed? It's the atomic structure, the arrangement of atoms, and how their electrons interact. Take indigo, the dye behind blue jeans. Its color comes from a particular arrangement of carbon, hydrogen, and nitrogen atoms. Change just one atom, and the whole molecule shifts. Suddenly, the electron jumps absorb different wavelengths, and your jeans might turn purple or green instead. This atomic switch is so sensitive that even swapping a single atom out, a nitrogen for an oxygen, for example, can alter the color completely. Chemists exploit this trick to design new dyes. By tweaking atoms, they tailor molecules to absorb and reflect exactly the shades they want, from neon yellows to subtle pastels. It gets even more fascinating. The atomic changes ripple out, affecting how dyes bond to fabric, how colors endure washing, and how light interacts with the fibers. Sometimes, the way a molecule bends or twists, again, all controlled by atoms, changes how it catches light, giving rise to shimmering effects or color fastness. So, the next time you pull a shirt from your closet or admire a splash of color, remember, it's not just fashion or chemistry. It's a story written at the atomic level, with each color depending on a tiny, almost invisible switch. These minuscule changes create the visible effects we experience every day, connecting the worlds of physics, chemistry, and art. And that's the magic behind fabric coloration, a tale worth knowing, hidden in plain sight. Follow Lorelight for more stories worth knowing.